In this explainer, we're going to dive into one of the biggest reasons software projects go sideways. They're built on a shaky foundation. We're going to explore how to develop clear, effective requirements, basically the blueprint that makes sure you're building the right thing from the very beginning. So let's get into it.
So let me ask you a question. Before you even think about writing any code, before you start picking out your favorite programming language or framework, what's the actual first step? Seriously, think about it. The answer really separates the good developers from the great ones. And here it is. It's actually pretty simple, but it is so important. The most critical part of any software project happens way before you write a single line of code. It's all about deeply, and I mean deeply, understanding the problem you are trying to solve. To help us get there, we're going to follow a four-part journey. First, we'll set the stage. Then we'll jump into the user's world to see things from their perspective. After that, we'll actually define our blueprint, and finally, we'll talk about how we gather, review, and adapt that plan as we go. So this first part is all about a mindset shift. We need to stop thinking like a builder who just follows instructions and start thinking like an architect who sees the big picture and makes a solid plan before anyone picks up a hammer. And this is why that mindset is so critical. A project's fate, whether it succeeds or fails, is often sealed before development even kicks off. Getting these requirements right from the start is your absolute best defense against building the wrong thing. I mean, think about it. This upfront work saves you a massive amount of time, money, and just plain frustration down the road. Okay, so now that we get why planning is so important, it's time to take our first real step. And that's immersing ourselves in the user's world. This is where we stop making assumptions and start learning to speak their language, to see the challenges they face every day. Now, the official term for this is domain analysis, but honestly, you can just think of it like this. An architect would never design a house without first understanding how the family lives, right? How they cook, how they relax. We have to do the exact same thing for our users. We need to understand their world. And the benefits of doing this are huge. I mean, when you really get the domain, you can communicate way better, which naturally speeds up development. You end up building a better system because you understand all the little nuances. And get this, you can even start to anticipate future needs, making your software way more future-proof. Now, let's look at a classic example of where things can go wrong right at the start. A client might come to you with a problem statement that sounds something like this. And on the surface, it seems okay, but this is a trap. It is way too big, way too vague to do anything with. A much better approach is to narrow that down to something focused, like this: helping students choose and register in courses that will lead to their degree. See the difference? This is specific. It defines a clear user, a student, and a very clear goal. This is a problem we can actually wrap our heads around and solve well. All right, so once we really understand the problem and we've narrowed our scope, we can move on to the main event, creating the blueprint. This is where we take all that knowledge and turn it into a concrete plan that developers can actually use to start building. So what even is a requirement? It's not just a feature idea. It's a formal statement, and it has a few key parts. It either describes what the system has to do, or it describes a constraint it has to work under. And maybe most importantly, it's a negotiated agreement. Everybody involved has to agree on it. And it turns out requirements come in a few different flavors. You've got functional requirements, which are all about what the system does, calculating fares, saving a file. But just as important are the quality requirements, how well it does it. Then you've got platform requirements, which define the technical environment, and process requirements, which are about how you're going to build it. And this is so critical, especially when you're talking about those quality requirements. The system must be fast is pretty much a useless statement. Why? Because you can't test it. It's not verifiable. A good requirement is specific and measurable. Search results have to appear in under 1 second. Now that is a clear target you can actually aim for and test against. A really powerful tool for figuring out those functional requirements is something called a use case. And don't let the name intimidate you. A use case isn't just a boring list of features. It's a story. It describes step by step how a user, which we call an actor, interacts with the system to get something done. And that brings us to the final piece of the puzzle. You have to remember, defining requirements isn't something you do by yourself in a quiet room. It's a team sport. It's a process of gathering ideas, carefully reviewing them, and then accepting that, things are going to change.
And there are a ton of different ways to get this information from people. You can literally just watch them work, you can interview them, you can hold brainstorming sessions, or you can build really simple prototypes to give them something to react to. Now, as you're gathering all these potential requirements, you're going to have to prioritize. And this is where the Pareto principle, also known as the 80-20 rule, becomes your absolute best friend. The idea is that, very often, you can solve 80% of your user's problem with just 20% of the features or effort. The trick is finding that critical 20%. So, as you review every single potential requirement, you can run it through this simple checklist. Does it actually solve the core problem we identified? Is it crystal clear, and can we test it? And this last one's important. Does it tell us what to do without telling the designers or developers exactly how to do it? You got to give them some creative freedom. And even after all that careful planning, after getting everyone to sign off, you just have to accept one fundamental truth about making software. Requirements are going to change. It's inevitable. Business needs change, technology moves on, and your own understanding of the problem gets deeper over time. So, if there's one thing to take away from this chapter, it's this. Your requirements document isn't a contract that's set in stone. It's a living, breathing guide. The goal isn't to stop change from happening. The goal is to manage it intelligently. And if you do that, you make sure that the software you end up delivering is the software your users actually need.